Now we can talk about capacitors. I have already discussed with you what a capacitor is. A capacitor is an arrangement to store maximum amount of charge in the smallest space. And I would say in the small space you have a large capacitance. And when we talk of these capacitors, one picture of capacitor I have shared with you here, it is electrolytic capacitor. In fact, the capacitors are made up of two plates. So, if you are looking at any capacitor, it would be consisting of two conductors, and these two conductors in the form of say parallel plate, they are kept some distance apart and one of them is earthen. So, this arrangement is called a parallel plate capacitor. And in addition to increase its capacitance, the space between them is filled with the dielectric of constant K. So, the whole arrangement of a capacitor is simple. It has two conductors placed some distance apart and the space between them is filled with a dielectric. This whole arrangement makes a capacitor. Now, this one which I have shared with you is a parallel plate capacitor. Parallel plate capacitor. Similarly, the two conductors can have the shape of concentric shells. So, think of that you have two concentric shells of radius R1 and R2 and the charge is supplied to the inner shell and the outer shell is earthened. So, here again you have got two conductors and they are now in the form of shells and the space between them is again filled with a dielectric of constant K. It is a spherical conductor, spherical capacitor. So, depending on the shape of these conductors, we are naming these capacitors. Similarly, the other example, the other shape of a capacitor could be a cylindrical capacitor where you will have two cylinders. The two conductors are in the form of two cylinders. The inner cylinder is provided the charge and outer cylinder is earthened. And once again the space between them is filled with a dielectric. This is a cylindrical capacitor. So, depending on the shape of these two conductors, we have different names of these capacitor: parallel plate capacitor, cylindrical capacitor or spherical capacitor. And there is one more important thing, and that is the dielectric. When we introduce the dielectric between the plates, then it increases its capacitance. And now you can understand why I have discussed the electric field passing through polar or non-polar dielectrics, because we wanted to know what will be the effect of dielectric when electric field pass through them. It is going to be of good use here in capacitance. And then when we are representing capacitors, we can represent capacitors like this or like this. There is a difference between them. A capacitor, this is the symbol of capacitor in your circuits. This is a fixed capacitance. This is a fixed value capacitor and this is a variable capacitor. So, this is a capacitor whose value can be changed. This is a capacitor whose value is fixed. So, they are the symbol of capacitors. Now, moving ahead, I have here some picture for you. Now, this is about types of capacitor. So here I have a flexed capacitor. Maybe you have seen these in the physics lab, or maybe if you have ever seen any electronic circuit plate like this, and then mica capacitor, then paper capacitor, then film capacitor, then ceramic capacitor, electrolytic capacitor, variable capacitor, and polyester capacitor. So there are various kind of capacitors that are available. They are used for different purpose, and mainly they are named after kind of dielectric that is filled between them. For example, if you have a paper capacitor, it means there are two conductors and it is the paper which is filled as a dielectric between the two conductors. If you have mica capacitor, it means it's a capacitor where mica is filled between the two plates. So one side we have shape of the capacitor, parallel plate, cylindrical or spherical capacitor, and other way of naming them is on the basis of kind of dielectric that is filled between them. Mica capacitor, paper capacitor, electrolytic capacitor, or film capacitor or polyester capacitor, it is all representing the kind of dielectric that is filled between the conductors. And here you can see, this is the picture of one of the electronic circuit plate, and there you can see here is the transformer, and all these are capacitors that are fabricated in the circuit. These are all capacitors, and this is resistor that we are going to study in the next chapter. So any electronic circuit has got so many capacitors to be installed. So it's a very important component of any electronic circuit or even electrical circuit. Now moving ahead, I can now talk about principle of a capacitor. So as I said, this is something which is very important to understand how it is possible to store maximum amount of charge in the smallest space, because those spherical conductors, they are not solving our purpose of high storage of charge. So principle of a capacitor is just based on the concept of potential that we have already learned. Let's start with, say we have a plate A. So I would call it plate A. And to this plate A, I want this plate to store maximum amount of charge. So what we do is, to this plate A, we are supplying charge, maybe through a battery. And when the charge is supplied to this plate A, obviously the charge get accumulated on this plate A. But question is, as far as space is, the space for accumulation of charge is concerned, any small plate A would be able to store infinite amount of charge. But the fact is, there is a limit to storage of charge, and that limit is because of the potential. Because as you are developing the charge on this, its potential is rising. And when its potential is rising, then certainly the electric field around it is also gaining up. And there is a maximum value of electric field at which the electric breakdown of air take place. Electric breakdown of air will take place, air will ionize, and when air will ionize, the whole charge will leak through air air will become conducting and the whole charge of this plate will leak through air into earth. So we don't want that situation. We don't want that whole accumulated charge should be leaked into ground. So I would say that there is a maximum value of potential. I can call it breakdown potential. I am taking it by a number, say break down potential has a value 1000 volt for this plate. It means you can supply charge to this plate through a battery, and the charge which you can supply would be to the extent that its potential should reach to 1000 volt, not more than that. So once its potential reaches 1000 volt, you should stop, because if you are trying to further supply charge to it, potential will increase, air will get ionized, and the whole charge will leak into the ground. So the limit has reached. Now, but what actually we are looking forward is to have more capacity. To this extent, we can supply charge, state, no problem. But I want it to have more capacity. So in order to have more capacity, what we do is we bring another plate near to it. I could call it plate B. So this is step 2. I will bring another plate near to it. When I bring another plate near to it, then by induction, here there will be some negative charge. And on this side there will be some positive charge. So by induction, on this plate B, you will have some induced charge, on the closer side negative charge, and on the farther side positive charge. Due to this negative charge which is here, there will be some potential here. Its own potential was 1000 volt. But I would say due to this negative charge, there is going to be some potential here, and that potential can be, say, minus 10 volt. So this potential due to this negative charge is how much, say, minus 10 volt. But at the same time, due to this positive charge also, there is some potential here, which is not very far. And this positive, due to this positive induced charge, there is a potential, say, which reaches to plate A, is, say, plus 5 volt. So you can see, due to this negative induced charge, there is a negative potential which reaches to plate A, this is minus 10 volt, and due to this positive induced charge, the positive potential has reaches to plate A, which is, say, plus 5 volt. So if I say what is net potential? What is net potential of A? It will become 1000 minus 10 plus 5. So potential of A would be 995 volt. Now you can check. You can see that by introducing this plate B near to it, without removing any charge from plate A, the potential of plate A is reduced from its maximum value of 1000 volt to 995 volt. So the result is that here you are having a reduced potential, and that reduced potential on plate A is how much now? 995 volt. So as a result, some more amount of charge can be supplied to it, if some more amount of charge is applied, it will not be easily reaching to 1000 volt, although it is just a gap of 5 volt left. But still, this induced charge, this induced potential will always reduce the value from its actual. And then in step 3, we can do another thing, and that is let us earthen this part, plate B. If we do earthing of plate B, as a result, what will we get is that whole charge positive over here will now leak into ground. But this negative charge, because of the attraction of this positive, will remain here. And the advantage of that will be that if earlier it was reducing from 1000 to 995, now it will reduce from 1000 to 990, because that plus 5 is not there. Only minus 10 will be impacting here. So there will be further reduce of potential of plate A. So by earthing the other side, the advantage is that you have more impact of reduce of potential here, and thus its capacitance is increased further. So you can supply more charge than usually you can supply due to the limit of electric breakdown. So this is principle of a capacitor. Very simple. You have a plate, you supply charge to it, and then its electric breakdown potential reaches. What you do is you bring another plate close to it. Onto this second plate, you have some induced charge on inside as well as outside. Due to induced charge, you have a potential decrease on plate A. But if the outside of plate B is earthened, as a result, you have more better effect on plate A, or in form of reduce of potential, and thus its capacitance is increased. Now, it is the same in case of any shape. If you are talking of, say, spherical capacitor, there also the same thing. You will supply charge to the inner one. So this is kind of plate A here, and this is kind of plate B, which is outer earthened. So inside there will be a negative charge, and thus this will have an increased capacitance of this inner plate of radius A. Similarly, you can take the case of a spherical capacitor. You have this cylindrical capacitor where you have this inner cylinder and it is surrounded by this cylinder. The inner cylinder is the one which is supplied with a charge, and the outer cylinder is earthened. So this induced charge, negative charge, induced charge is there, and due to this, this inner cylinder will have more capacitance than usually it could have. So this is principle of a capacitor. And now moving forward, I talk further, and that is that one side it is clear, like this is a parallel plate capacitor. So you have two parallel plates separated some distance apart. They do have increased capacity. We call them parallel plate capacitor. But in order to further increase its capacitance, so you have a parallel plate capacitor. Idea is clear to us now. In order to increase its capacitance further, the space between them is filled with a dielectric of constant K. So if earlier its capacitance with air, if its capacitance was C with dielectric, it is observed that its capacitance become K time of C. Now there is a big change. If K is 81, capacitance will be 81 times. If K is 2000, capacitance will become 2000 times. So this introduction of this capacitor, introduction of this dielectric between the plates of capacitor, increases its capacitance manifold, K time. Now, how it happened? So in order to understand that, I would just take the simplest idea of this, and this is, say you have this first plate A and here you have second plate B. Once you fill the dielectric inside of constant, say K, then in the dielectric also there is induced charge. That induced charge is minus here and plus here. So you can imagine that this minus charge, which was reducing the potential of plate A earlier, have reached so close. So this induced charge, which is in addition to this induced charge which is impacting the potential, which is decreasing the potential of plate A, has reached so close, and that's why it increases the capacitance manifold. So this is all about the principle of a capacitor. When we talk about capacitance, there is a formula. We know Q is equal to CV, and capacitance of a parallel plate capacitor, cylindrical capacitor or spherical capacitor will be just Q by V. So it is that formula we have already learned. Capacitance is Q by V, where Q stands for amount of charge stored in plate A and V stand for not the potential, potential difference between the two plates. So V here would stand in capacitor potential difference between the two plates. And there is one important relation we are going to use here, E is equal to minus dV by dr. Generally we say electric field is what? Minus dV by dr. This is something, just a basic idea I am giving, which is going to be useful in the expression. So electric field is what? Minus dV by dr. Electric field is negative of potential gradient we have done. Now just imagine that you have got two plates here. I am concentrating on this. Electric field is minus dV by dr. So you have two plates here, plate A and plate B. And the potential difference, the separation between them is d, and also the potential difference between them can be, instead of dV, we call it V in the capacitors. So if you are relating with the electric field, kind of amount of electric field here, so this relation is E is equal to V by D. Here in capacitors, we represent the electric field, potential difference between the plates, and separation as E is equal to V by D. This is something which we are going to use in our expressions. V stand in capacitor, not potential. V stand for potential difference between the plates, and E is the electric field between the plates.